Let us study about principal stresses and principal plane. What do you mean by a principal plane? Principal plane is a plane in which shear stresses are absent. Shear stresses are absent or are zero. So the plane in which shear stresses are zero, see, this is a 3D element. So in this 3D element there exists three perpendicular plane in which shear stresses remain zero. So that plane is called principal plane, and the stresses, the normal stresses in acting on those plane, let us represent that as sigma x, sigma y and sigma z. Those stresses, sigma x, sigma y and sigma z, are called principal stresses. Normally we represent it as sigma 1, sigma 2 and sigma 3. Okay, this is we represent as sigma 1, this we represented as sigma 2, this we represented as sigma 3. So that is what it mean by principal plane and principal stress. Principal plane means it's a plane in which shear stresses are zero. If we consider a particular point, if we develop the 3D element of that, we will have three planes, three orthogonal planes in which shear stresses are zero. That planes are called principal planes, and the stresses normal to that are taken as principal stresses. So that is it regarding. So this principal stresses, it will be maximum or minimum. So we will have to develop the equation, or we will have to find out the plane in which principal stresses or maximum or minimum stresses occur. So we have an equation for sigma n stresses on the normal stresses on the oblique plane as sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus 2xy sin 2 theta. This we have already studied. Okay, so in order to that sigma n to be maximum or minimum, we will have d sigma n by d theta should be equal to 0. So we will have, differentiating this term, we will have sigma x minus sigma y by 2. Instead of cos 2 theta, we will write 2 minus sin 2 theta, and 2xy into cos 2 theta. So that will be equal to 0. So we will have sigma x minus sigma y by 2. Here this 2 and this 2 will cancel. So we will have sigma x minus sigma y minus sin 2 theta is equal to minus 2xy cos 2 theta. So that will become, taking this side, we will have this negative and this negative will cancel out. So tan 2 theta is equal to 2xy by sigma x minus sigma y. Okay, so tan 2 theta is equal to this value. So this is our 2 theta. If we this is the plane in which we will have principal stresses. Let us take it as this theta as theta p, that p represent principal planes. So tan 2 theta p is equal to 2xy by sigma x minus sigma y. Okay, in this plane, when this value of theta occurs, then we will have principal planes and principal stresses developed on that. Okay, so that is regarding the principal stresses and principal planes. So we will have to substitute this value of tan 2 theta p. Then we will get the value of sigma 1, sigma 2 and sigma 3. Okay, so sigma 1, sigma 2 and sigma 3, in this 3, sigma 1 will be, or take any one, whether it be sigma 2 or whether it be sigma 3, one will be maximum and one will be minimum and one will be intermediate. So we will have to consider only maximum and minimum. So we will here consider only sigma 1 and sigma 2. We are neglecting sigma 3, we take it, considering sigma 3 as an intermediate value. So we are taking sigma 3 as an intermediate value, so we are neglecting sigma 3. We are concerned here only about the maximum principal stress and minimum principal stress. So we will have, see, for an element tan 2 theta p, see here 2 theta p, if we represent here, see, we will have this one, see, 2 theta p is equal to 2xy by sigma x minus sigma y. That can be represented like this. if we are taking an angle like this 2 theta p, then tan means sine by cos, na? So tan means opposite by adjacent. So if we can write like this also, 2x by sigma x minus sigma y by 2. Like this also we can represent this one. So tan 2 theta p will be opposite by adjacent, means opposite can be represented as 2xy and the adjacent can be represented as sigma x minus sigma y by 2. Same thing, na? Tan 2 theta p, so opposite by adjacent, so tau xy by sigma x minus sigma y by 2. So opposite by adjacent, like this we can represent it. So from this you can find out what is the value of cos 2 theta and sin 2 theta, and putting in that value of sigma n, we can find out the value of sigma 1 and sigma 2. Okay, let us do that. Sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. Instead of cos 2 theta, we will have to find out cos of this one. See here, this portion will be tau xy square plus sigma x minus sigma y by 2 whole square, because that is the hypotenuse, na? So cos 2 theta will, let us put this as r. Okay, this value, root of this value as r. Okay, for simplicity. So sigma x minus sigma y by 2 cos 2 theta. Cos means that adjacent by hypotenuse, so that will become sigma x minus sigma y by 2 by hypotenuse will be r. Okay, then plus sigma x plus by sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta, this much has become, plus tau xy sin 2 theta. Tau xy sin 2 theta. Sin 2 theta will be what value? Sin 2 theta will be, sin 2 theta will become opposite by hypotenuse. Opposite will be tau xy by hypotenuse. Hypotenuse will be r. So this will be our value. So we will have sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square by r plus 2xy square by r. So this will be sigma x plus sigma y by 2 plus, see this will be the value of sigma n. Sigma n sigma by 2 plus this sigma x plus sigma y, sorry, we can take 1 by r in common, na? Sigma x minus sigma y by 2 whole square plus tau xy square, this much term. So we have sigma x plus sigma y by 2 plus 1 by r. 1 by r is what value? 1 by root of tau xy square plus sigma x minus sigma y by 2 whole square into same thing here. Let us rearrange. Tau xy square plus sigma x minus sigma y by 2 whole square. Okay, so this is this much we can cut and put it under root. So that will become, this is 1 by 2n and this is 1. So we can cut and put 1 by 2 here. So we will have sigma n. Sigma, now this has become not sigma n. Instead of sigma n, it has become principal stresses. So we will have sigma 1 2 is equal to, see this one under root we are cancelling, so that will become sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 whole square plus tau xy square. Okay, cancelling this out and putting it under root, we will have this value. So plus or, because we are putting under root, we are taking plus or minus sign. So if it is plus value, then it will become maximum stress. This is maximum principal stress, and that is when this value is positive. Okay, and we will have sigma 2 as minimum principal stress when this value is negative. Okay, so that is regarding principal stresses.